Okay, in this problem I'm going to talk about what do we do for this equation whenever I have different functions, cosine and sine, and none of them are squared. How in the world can I convert between the two? I don't have an easy conversion between cosine and sine. I do have an easy conversion between cosine squared and sine squared because I remember that cosine squared plus sine squared equals 1. So how do I create squares? Excuse me. And the solution is to do this. Your first step, and this was perhaps the most counterintuitive of all the problems that we're going to work with, is going to involve when do we do this? I can square both sides. On the left-hand side, I've created a difference of squares. So I really need to FOIL this out. That's cosine x plus 1, cosine x plus 1. But on the right-hand side, if I'm taking sine times sine, it's just sine squared of x. Now, to FOIL this out, I need to do cosine squared x plus 2 cosine x plus 1, and that's equal to sine squared x. Now, it looks like I can convert, and it looks like I want to convert everything to cosines. Why? Because this one is going to be tough to turn into a sine. So I'm going to turn everything into cosines. I'm going to replace sine squared with its equivalent from the Pythagorean identities. I'm going to replace that with 1 minus cosine squared of x, because sine squared plus cosine squared equals 1. Alright, now, I'm going to throw everything on the left-hand side of the equation. I'm going to set it equal to 0. I'm going to factor it to solve it, just like we're doing a lot of the other problems. So let's see. I can add this cosine squared over, which means I get cosine squared plus cosine squared. I have 2 cosine squareds on the left now. I got no cosine to the first power except this one. And then over here, I have the 1. If I subtract 1 from both sides, I have this 1 minus 1. They go away. I'm left with 0. Now I'm going to factor to solve, if at all possible. I notice I have 2 cosine of x on both sides, on both terms. So I'm going to pull that out, and I'm left with cosine x plus 1. That's equal to 0. So there's 2 ways that this can go. First of all, I can divide both sides by 2 here. That goes away. It's really the same thing as cosine of x is 0 over 2, which is still 0, right? So I don't need to worry about that 2 out in the front. 2 things that can happen from here. Cosine x can be 0, and from here, cosine x plus 1 can be 0. So I go through, and perhaps if you don't want to do the graphing method that we've done in all these other problems previous leading up to this, you could always do this. You could say, alright, arc cosine of 0 is 90 degrees. We better check and make sure that the other axes then aren't. Cosine of 180, no, not 0. Cosine of 270, oh, that's 0 as well. On the unit circle, if I remember that this is related to the x-coordinate of the unit circle, whereas x0, well, that happens at 2 locations, 90 and 270, right? So x can be pi over 2, that's 90 degrees. It can also be 3 pi over 2, that's 270 degrees. Now let's go worry about this one. Cosine of x is equal to negative 1. And by the way, I can even use the same approach. Knowing that this is the x-coordinate on the unit circle, where's the x-coordinate negative 1? Well, that's only when you go as far left as you possibly can. That's at 180 degrees, or pi. And there's your solution to this problem. We would do the same thing over here. I've got sine and cosine, they're both the first power. I don't know what to do, so I'm just going to square both sides. So on the left, I'm going to skip a couple of steps. I'm going to cheat off of what I've already done. I'm going to have sine squared x plus 2 sine x plus 1, and that's going to be equal to cosine squared of x. And now, because this sine is going to be very hard to convert into a cosine, I'm going to change everything into sines based off of this. So I'm going to replace this with its equivalent of 1 minus sine squared, and I would go through the same steps from there. Now, you're going to get pretty similar results as whenever you do this. It's going to be axes answers, except they're going to be different. They'll be slightly different than this, but you're going to get the same idea. I'll let you work that one out on your own. Keep in mind, this whole time we could have done this. Left side of the equation is sine of x plus, in parentheses, plus 1, and the right side of the equation is cosine of x. And that's supposed to be plus 1. There we go. And I could have said, okay, between 0 and 360. And the only reason I'm using degrees instead, the only reason I'm using degrees is because the numbers are going to make a lot more sense to me. If I graph this from 0 to 360, I'm going to see, here comes the sine of x plus 1. And here comes the cosine of x. I'm going to see those only meet up at a couple of locations. And those locations are 0 degrees, or 0 radians. Secondcalc intersect. Let's move the cursor over here. Looks like they meet somewhere around here. Inner, inner, inner. Turns out they also meet at 270 degrees. That's 3 pi over 2. And then it looks like they meet up again at 360 degrees. But when we are answering this problem, we are told originally in the instructions to go between 0 to 2 pi. And because this is rounded, that means that 2 pi, 360 degrees, is not an actual answer that we can provide. It's anything up to it, like 359.999999999999999 degrees. Okay, that's fine. But 360 degrees is not. So we're not going to include 360 in our answer. That means that our two answers in radians are 0 and 3 pi over 2.